Global average temperatures are expected to increase by about 2 to 13 degrees Fahrenheit by the end of the century. That may not sound like a lot, so what's the big deal? The problem is that small changes in global average temperature can lead to really large changes in the environment. Only a few degrees have made the difference between ice ages, temperate periods, and a hothouse Earth with green poles. During the last ice age, global average temperatures were only 7 to 13 degrees Fahrenheit colder, but ice plowed as far south as Illinois. About 125,000 years ago, average temperatures were only a degree or so warmer than today, but sea levels eventually rose as much as 20 feet higher. Small changes in the global average temperature also mean heat waves get hotter and droughts get drier. This happens thanks to small changes in the way air and water circulate around the globe. For instance, during the wetter and cooler climate of the last ice age, the Great Basin of California was filled by a great lake ringed with pine forests. When the climate became warmer and drier at the ice age's end, the lake dropped 500 feet and lost 90% of its surface area. The pine forests became sagebrush desert. Such changes in precipitation could be just as important, or even more important, than temperature increases for many parts of Earth. These effects are not temporary either. The climate is like a large ship. Once it starts turning, it's hard to stop. Whatever the new direction is, it will affect your children, your grandchildren, and many generations after. What will a changing climate mean for us in the future? Scientists make the best assumptions they can using models to project what might happen. But we don't know for certain what will happen or when, because we don't know what choices people will make about changing energy sources, limiting population growth, preserving forests, etc. Some impacts are more certain than others. Some will occur sooner and others later, and some will affect developing nations more than wealthier ones. Of course, there will always be natural variability, with some places and some years warmer or cooler than average. In general, however, summers will get hotter, not only because of higher temperatures, but also because humidities will increase. A warming trend on top of natural variability means that temperatures will cross today's heat thresholds more often. For example, the 2003 European heat wave that killed 35,000 people was a combination of global warming and extreme natural variability, and could not have happened without both. Models predict that in many places, an extreme heat event that we only see once every 20 years today will happen once every 3 years by the middle of this century, and even more frequently by century's end. On the plus side, winters will be warmer in many places, reducing heating bills, and the number of days with frosts is likely to decrease. On the downside, it means more snow may fall as freezing rain, making ice more of a problem for motorists, pilots, and seniors. Because a warmer planet will boost evaporation and change atmospheric moisture circulation, many dry areas will become drier and wet areas wetter. In North America, on average, precipitation is likely to be less frequent but more intense when it does fall. This may mean that the American Southwest becomes drier. Indeed, we have already begun to see these trends in the past few decades. And along with increased droughts comes an increased potential for wildfires. The oceans will continue their rise in the coming century. The IPCC's best estimates range from a few inches to a few feet by 2100. If seas rise 2 feet, the United States could lose 10,000 square miles of land surface, mostly on the Gulf and Atlantic coasts. If they rise 3, they will inundate Miami and most of coastal Florida. Sandy shoreline erosion happens at about 100 times the rate of sea level rise, so a few inches increase in the ocean level can greatly affect coasts. And since nearly half of the world's population lives in low-lying coastal areas, Continued population growth along coasts increases vulnerability from sea level rise, storm surge, and flooding. Everywhere, coastlines will flood more often, particularly in cities not rich enough to build seawalls or adapt in other ways. Salt water will spoil many freshwater aquifers that provide drinking water. And the loss of coastal wetlands is not trivial. One estimate projects 17 to 43% of U.S. wetlands could be submerged, of which more than half would be in Louisiana. Though new wetlands will form farther inland, their total area will probably be reduced, which would put New Orleans and other coastal cities at even greater risk from hurricane storm surge. The IPCC's projections are at best a rough estimate, however, because we don't know how much and how far the planet's great ice sheets will melt. Meltwater draining through the Greenland ice sheet and newly discovered hidden lakes trapped under the Antarctic ice sheets contribute to uncertainty about how much seas may rise in this century and beyond. The complete loss of either the West Antarctic ice sheet or the Greenland ice sheet could eventually raise sea levels on the order of 20 feet. What do you think? How do you think hurricanes are likely to be affected by global warming in the future? This actually is a subject of considerable scientific debate. Scientists are not sure whether the frequency of hurricanes will change, but they think that those that do form will likely be more intense with stronger wind speeds and heavier rain. Answer C. Studies suggest that for every 1.8 degree Fahrenheit increase in tropical sea surface temperatures, core rainfall will increase by 6 to 18%, and surface wind speeds of the strongest hurricanes will increase 1 to 8%. Storm surge levels are also likely to increase. However, some studies suggest that vertical wind shear increases may reduce hurricane activity, at least in some areas. We don't have enough data on tornadoes to determine whether their frequency or severity is changing, and global climate models can't currently simulate features as small as these storms. While winters will be warmer overall, when storms do occur, they will likely produce more snowfall, stronger winds, and higher waves, although these effects may vary with location.